Here we go. Welcome everyone to DIGA694. The purpose of our video recording here is to highlight some of the capstone defenses or the capstone presentations for DIGA694. The capstone experience is one in which all of our presenters here this evening have embarked upon a journey 13 weeks, actually 14 weeks ago, on a particular analytical project or topic of their choice to explore and or examine and or to study. And so with that, everybody that is involved in Capstone has been part of a data collection process. So they have a topic and a data collection process to which they have designed a methodology to analyze the topic that they're interested in exploring or studying. And then of course they have analysis methods with that. So this moment for this video for our particular presentations here will be a summative presentation of their capstone work, which includes the data integrated into their methods and an analysis with some of their findings. So they are here to share with you all some, or at least a kind of a preliminary outline of their findings. And the goal of the capstone presentations here is to solicit feedback on what they could improve and what else they might examine or take a look at with what they have right now, so that we can bundle up any loose ends as we move forward towards the end of the capstone course in several more weeks. So with that, we have a number of presenters with a lot of very interesting topics here this evening. And a special welcome again to all of us joining live here, as well as those of you who may be watching this after the fact in a recorded, comfortable setting of your choice, perhaps. But here's our list of presenters, and we will do our best to stay on time and on track for this. So with that, what I would like to do is welcome our first presenter, Harshita. And Harshita, I will stop my screen share and then let you share your screen out. And then I will give you a little introduction.
I'm going to sharing my screen.
Yep, go ahead and share your screen. Okay, Harshita has her screen up and ready to go. So Harshita's embarked on a journey that has taken her through a little bit of the healthcare sciences, in addition to what are some of the opportunities and tactics that we can use to examine different types of healthcare needs and assessment of those needs from a spatial dimension. And so her study was on COVID-19 spread and how communities, how responders, how healthcare, I'll call them organization or entities, were able to provide resources and allocate those resources for her particular study area that she'll be telling us about. So with that, Harshita, I will turn it over to you, and at the end, we'll have opportunities for some questions and Q&A from everybody. So with that, we'll turn it over to you, Harshita.
Yeah. Thank you, John. So, hi all, I'm Harshita. Today, I'll be presenting my final capstone project titled GIS Case Study on COVID-19 Spread and Healthcare Resource Allocation in Delhi. So basically, this project integrates the geospatial technology and the public health to analyze how COVID-19 impacted different regions of Delhi and how GIS can guide more equitable healthcare resources planning. It represents the research and combines with the both spatial mapping and statistical modeling. I'm going with the second slide outline. So we're going to discuss few of these things in my slide: introduction, study area, methodology, data use, results, discussions, limitations and recommendations, and conclusion at last. So I'm going to start with my introduction. COVID-19 changed the world drastically, but in highly populated cities like Delhi, it wasn't just a health crisis, but it was also a crisis of inequality. During the second wave of COVID-19 in 2021, Delhi saw hospitals like overwhelmed, oxygen shortages, and also poor emergency coordination. But something deeper was at play. Like not everyone had the same access to care. Where this is where the GIS comes in. The GIS allows us to map and analyze and understand the spatial patterns. Slideshow. So my project used GIS to analyze like where COVID-19 cases were concentrated, where the healthcare resources were located, and how testing impacted case detection. Ultimately, this project shows how spatial tools can inform better, fairer public health responses. And why should we care about this research? During Delhi's second wave, media reported horrifying scenes like people asking for oxygen and overrun testing labs. Why did this happen? The major reason for this is like planning wasn't spatial. Like while countries like South Korea use GIS for real-time decision making, India like they have fragmented systems and manual tracking. This study fills that gap. So it shows how GIS based mapping combined with testing data can offer the life-saving insights. So if this had been in a place, lives must have been saved. The main goal of this project was to explore how spatial and statistical tools could help and understand and address the healthcare challenges during the COVID-19 in Delhi. Firstly, I aim to analyze the geographical spread of COVID-19 cases at the ward level, providing a more localized and detailed pictures how the virus impacted on different parts of city. Second, I evaluated the accessibility of the healthcare facilities by mapping to identify areas where we have the high case counts were not matched with the nearby hospitals or clinics. The third was to determine the relationship between the testing volume and the detection through the linear regression. Finally, to offer the spatial insights that could help inform more equitable and efficient healthcare resources allocation in future public health emergencies. Although these goals aim to bridge the gap between data, geography, and the policy. I'm going to say about the study area. Delhi is just not a city, it's just a perfect case study. So, with the population of over 200 million residents, strategically located in North India, Delhi is one of the most populated urban centers. Sure. Uh, Can you see me?
All right, we're back. Go ahead there, Harshita.
So, I'm going to start about the study area. So Delhi is not just any city, but it's just a perfect case study. Like with a population of over 20 million, Delhi is one of the world's most populated urban centers, which is divided into 11 districts, about 300 wards, each with very different living conditions. Some some have access to modern hospitals and infrastructures, and others are informal settlements with no proper sanitation, dense housing, and no healthcare nearby. I focused on the ward level analysis, especially in the Niteri ward in the northwest Delhi, a place with historically low representation in planning but high population density and case burden during COVID-19. This diversity makes Delhi a microcosm of Indians' urban health challenges. I'm going to talk about the methodology. So, I'm going to talk about the data. The first step was the data collection. I gathered the data from the mix of open public platforms, and the official government sources. Like COVID-19 case data was collected from the Delhi Health Department as like ward-wise based on 2020 to 2021. And testing data was collected from the COVID-19 Indian organization, healthcare facilities locations from the Open Map Street, and demographical data from the Delhi Municipal Corporation. So together, these data forms from foundation for both mapping and statistical modeling. Data cleaning and standardization. So all the spatial data were reprojected to a common coordinator system like WGS 1984. This ensured the alignment across all layers in the ARCGIS Pro, ArcGIS Pro. The COVID case and testing numbers were standardized per okay, yeah. So that the wards with larger population wouldn't skew the results. Healthcare facilities were categorized based on service capacity, like ICU availability and the bed availability, oxygen support, and the general bed count ensured consistency across the data sets from the different sources. And I also resolved issues like missing values, duplicate entries, and formatting the inconsistencies. This step was crucial to ensure the accuracy and compatibility of the data across different sources. Then mapping. Then I move into the mapping stage. The first layer of spatial analysis was the spotting mapping using ARCGIS Pro. So I used the Delhi Ward Boundary 2022 shapefile to create the ward level polygons. Then I used the color coded for each ward based on the number of COVID-19 cases using graduated symbology. As you see, the yellow are from the for the low case counts, and the orange for the medium case counts, and at last red for the high case counts. This allowed me to visually identify the clusters of the infection, especially in the outer wards like the north, east, and the south Delhi. This heat map revealed where the virus was most active and where intervention efforts were more urgent. Then each facility was represented as a red dot and filtered to include only within the Delhi boundaries. I visually compared the density of the healthcare facilities against the high case zones. What I found was concerning. Many wards with highest COVID cases had very few or no even healthcare facilities nearby, especially in the outer zones, where the informal settlements exist and access to care was extremely limited. So the spatial mismatch was one of the key findings of the project. Then I'm gonna go into the linear regression. In parallel with mapping, I conducted statistical analysis to qualify the relationship between the testing volume and confirmed COVID cases. I used daily data covering 488 days, and I ran a simple linear regression in Excel with I'll show the So linear regression in Excel with the model produced was R square of 0.953, meaning that 95.3% variation in case detection was explained by the testing volume. And the slope of the regression equation suggested that for every 10,000 tests, approximately 262 new cases were identified. And then the p-value was zero, indicating the strong statistical significance. This proved that testing was not just diagnostic, it directly influenced how well the city could detect and respond the virus. Then I'm going to go with the visual interpretation. I usually combined all the spatial and statistical outputs for interpretation. I use RGS Pro where I created the maps, where the infections are high. And using Excel, I built the regression model, bar chart using the trends over time. These visuals help interpret how geographical and population density testing and healthcare access combine to shape Delhi's COVID-19 outcomes. Then the data collection and the data preparation. With the here the main data sets are used. As I told, COVID-19 case data from the Delhi Health Department and from testing data from the COVID-19, hospitals from the Open Street Map and demographics and the boundaries from the Delhi Municipal Corporation. And the data preparation was like all layers were projected into the WGC 1984 coordinating system. And hospitals were characterized by ICU presence, bed count, and oxygen support. So this level was detailed were crucial in identifying not just where the hospitals were, but if they were equipped with to handle emergencies. And these are my results. So I use this map as I already told. The red was showing the high case areas, orange were medium, yellow were low. What we observe through this is the outer wards, particularly in the north, east, and south, Delhi had the highest number of cases. They're also the places with the least access to healthcare. We'll see in the next slide. So, so here the wards colored based on the low were 1 to 50, medium were 50 to 115, and 115 to 401. So these help me to visualize the clusters of infections across Delhi. And as I told you, this is the purpose, like to identify the spatial gaps in the healthcare and also support the policy recommendations for more equitable resource distribution. And I'm going to talk about the case trends over time. This bar chart usually daily case trends from April 2022, August 9, 2021. This notice the major peaks during the mid 2020 and spring 2021. These match the timing of first and the second waves. This visualization helps the context when Delhi was most overwhelmed and more when policy action lagged. So then the discussion. So the spatial disparity has many needed areas lacked with the hospitals and the clinics and the testing inequality. Richer wards had more testing and leading to the faster response. Statistical strength, the regression provided the expanded testing equals more accurately. Global relevance. This matches patterns in countries like South Korea, which use GIS dashboards to plan resources dynamically. Then the limitations and challenges. So every study has its limitations. So some of the COVID-19 cases were maybe gone unreported, especially in the slums. Testing was more accessible in few areas where the skewing results. Hospital data lacked clarity on which ones were operational. Linear regression assumes a simple relation, whereas the real world is more complex. Still, these do not validate the findings, they emphasize the need for better data collection and real time systems. And the recommendations to develop the real time GIS dashboards to track outbreaks and the resource gaps live and prioritize the deserved wards when allocating the resources. Expand testing has preventive measure, not just a diagnostic one. Apply this model to other cities like Mumbai or Bangalore for broader insights. This goal is not just to respond, but just to be prepared. So I'm gonna add a slide like contributions to this field. Like this project contributes to the both GIS and the public health. This shows the GIS isn't just for the maps, it's like a decision tool making. It supports equality in healthcare policy with the data and also visualizes the invisible inequalities. GIS can guide not just what we see, but also what we choose to do as planners and the leaders. The conclusion, to summarize, COVID-19 exposed the systematic spatial inequalities in Delhi healthcare system. GIS revealed that high needs wards had the least cases to care. A statistical analysis confirmed the vital role of testing. Together, GIS and the data science offer a blueprint of future pandemic prepares, preparedness and also health equality. And, and thank you for your time and attention. And I would really thank my instructors, Dr. John and Heather, for mentorship and the guidance. And also thank you to my classmates for your support and the feedback throughout the project. And if you have any questions, please ask. Thank you.
Thank you, Harshit. The one question, so obviously this is a, kind of it's a preliminary result of your work, and we're still going through and refining everything yet for everybody. And that's why having the presentations a little bit on the front end of that can be helpful, because it gives us a chance to get a little bit of feedback for that. What kind of more of a just general question, what made you interested in this topic?
So basically, I'm from India, right? So, and the Delhi is like very populated area, and we have seen lots of cases from there, and lots of we basically people were not having so much hospitals and hazards like oxygens, all those things. So I just wanted to visualize with the GIS how it can be possible, like to visualize the results and all the viruses with the hospitals.
Okay, let's see here. We'll take a couple other, and I'll have some more too in your paper, so don't worry. Miss Hamsbon and I will be giving you plenty of comments back here. But other questions that people might have. Oh, one final one there. But Rob, did you have a question or? I'm not able to hear you, Rob.
There we go. Okay, is that better?
Yep.
All right, cool. Harshita, I noticed that you had included that hospital and clinic data was from OpenStreetMap as well as the in.gov website. Did you find that the government data was incomplete? Did you need to supplement it with other data? How did you kind of decide how to use those two data sources?
So basically, I got this from the Delhi Municipal Corporation thing, the data's everything. I felt few were so incomplete, so I couldn't just add into the data. So I got only few. So I was like, okay, I just want to use these virus and the hospital things, so which can be easily mapping to show the people easily mapping.
Cool, thanks.
Other questions or comments? Thank you, Rob. That was a good comment. Can you comment, Harshita, on, we'll see, maybe we'll get time for maybe two more questions here. What surprised you the most in the experience with Capstone?
Like with the project?
Yep. Yeah. What surprised you with when you set out on this journey to do all the work, and people that are watching the recording obviously did not or yet see your paper, where we're working on those. So there's a lot more detail in those your paper, of course. But what surprised you the most through the entire experience?
Surprise, like when I was doing the GIS mapping and the regression, the statistical thing, I felt very interested to visualize the hospitals and the virus, where we can say the people that we have this limitations in the Delhi thing, which is very low of hospitals, and that's all.
Yeah, it's a different experience. Like some people they find out a lot about themselves and how they think and how they respond, or they learn something about data that is insightful, that was new, that maybe didn't realize. Ms. Samswell, was there any questions that you might have as we conclude Harshita's time here for her presentation?
Yeah, I was just going to ask if you could talk a little bit about, so the data you chose was concentration of cases and hospital locations. So how did you end up settling on those components to determine your, or just as your criteria? Like, what would you have, when you first came into this project, were you just like, that's exactly what you wanted to do? Or did you like kind of work into that data based on what you found out there?
I really want to choose the COVID-19 cases back then because it was a essential news, right? So in India also there were so many cases, especially in the populated areas. Like I have first had chosen the three states like Delhi, Mumbai, and Bangalore. But for the Mumbai and Bangalore, I couldn't find any data, correct popular the correct proper data for that. I found for the Delhi, then I wanted to choose and say that how spatial inequality affected the areas in the Delhi with the COVID-19.
And do any of the hospital locations, do you know, is it based on like population of the area that they're in? So are there less hospitals? Like, does that affect the fact that there's less hospitals, or is it pretty even population through all those wards? I don't know if you know the answer to that. I'm just, did population factor in it at all? Like,
I think population factors really matter a lot in here. I feel because more people got into this virus and less hospitals are treating them, and I feel very sad. And I just want to show us regarding as a mapping thing, so people can identify where the hospitals are there. So where are the less hospitals, so we can get the sufficient things into the hospitals which can make the uh, patients in a good state.
Thank you, Harshita, for that, and Ms. Amswell for your comments, Rob and others as well. And so with that, just being mindful of time there, we will congratulate all of you at the end here. So Harshita, very nice job. Looking forward to seeing the final development of your paper. And so what we will do, Rob is issuing you some congratulations there. So I would invite you to take a look at your presentation and reflect upon that, and take a little bit of an examination into, I think, explaining, Rob kind of talked a little bit about that, explain a little bit of your data and your rationale, a little bit more of choosing that, kind of where you went with that, and that very well as it could be in your paper too. So those are just some things to take a look at. Be mindful of the visuals, making sure that all of our visuals in your paper, that is, are clean, descriptive with good captions and everything like that. But otherwise, there'll be more comments to come. So Harshita, congratulations to you. Thank you for a nice job.
Thank you so much.
You're welcome. So you can end your screen share and I will pause the recording and we will get our next presenter up here momentarily. All right, we are back. Our next presenter is Tony Rossini. He is embarked upon really a creative R&D opportunity that we have had some ongoing partnership relationships with. So a lot of his work is inside or related to a very neat and innovative partnership looking at, there's sprinklings of AI, but it's a little bit more in the deep learning aspect of how we are able to use classification to attach meaning to maybe different objects or locations and then relate that to data. Specifically in this case, we're looking at different types of grocery models and store locations and store volume, and Tony will explain that much more eloquently than I am able to at this moment, being that he was running the show for obviously his capstone here. So title of his work is Automated Site Selection and Classification Using Aerial Imagery and Deep Learning Techniques. So Tony, the floor is yours.
Awesome. Thank you. Yeah, like John said, my name is Tony, and yeah, this is my project, Automated Site Selection and Classification Using Aerial Imagery and Deep Learning. I will be, I have a lot of slides here, so I might actually skip over some of them for time, so I apologize for that. So just keep that in mind. But yeah, so an introduction here, the project goal was to create and understand the feasibility of a data-driven and automated aerial screening tool, specifically for grocery stores. And so kind of what that, at a very simplistic um, way, what that means is like I wanted to take an aerial image of a grocery store, put it through some predictive modeling, which included a regression model and a deep learning model to help us hopefully estimate how well that grocery store, number one, does in weekly total sales. And number two, if we can use the combination of the aerial imagery and deep learning to accurately capture the physical store features. And I'll talk about what those store features are pretty soon. But if this was successful, the screening tool would help reduce the need for manual data collection and site analysis. So I'm working with this company, Retail Stat, and they're a retail intelligence provider. And from my understanding, the way this is currently working is that they have they have contracts with all these grocery stores, and they send someone out to the grocery store to evaluate it. And they have do this manual process where they rate the grocery store on a couple different metrics and record that information. So this screening tool would help automate that process, and which would be very valuable because you'd speed up the time to evaluate hundreds and even thousands of sites, and hopefully you could evaluate all those sites, and then this model would tell you, hey, these are the 10 best sites that are likely to produce the most monetary value, or maybe you want to look at it a different way and say, hey, these 10 sites, they all have the best parking lots, or something along those lines. And so, yeah, like I said, yeah, I was working with this company, Retail Stat, and they provided me with a pretty large data set of all this grocery store data. So yeah, looking at the store locations, almost 9,000 stores across the majority of the United States and even a little bit into Canada. And the stores range from like your local grocery store that's pretty small all the way up to your large nationwide warehouse type stores like Costco, Sam's Club, Walmart, things of that nature. So pretty wide range of stores in this data set. Now, looking at the data itself, I got this data specifically from Jake Johnson, who works at Retail Stat, and he's actually an alumni of this program. So big shout out to him for getting me this data. And so after getting the data and looking it over, I identified the important fields as the store ID, latitude, longitude, the total volume. So this is the average weekly sales of the store. So whenever I talk about volume, that's what I am referencing. We also want to know the square footage of the sales area, so where the customers are shopping, and then the total square footage of the entire building. And finally, we make our way down to the 5 physical store features. So this is the main fields that we're interested in looking at. So these features, they're rated from excellent to poor. So excellent, good, average, fair, and poor are your 5 class options. And for this project, I did have to translate these character values to numeric. So that'd just be simply 5, 4, 3, 2, 1, respectively. And so yeah, we'll talk about these store features specifically now. So visibility, this is how easily the store can be seen from the surrounding roads. It also looks at where the main, like where the entrance of the store is facing. Is it facing the main road or not? Is the sign easily visible or not? Things of that nature. Traffic flow, has to do with how cars are getting around the store and in the parking lot, how easily they can do that. It looks at if there's a lot of traffic lights in the area, if there's one-ways. SC condition, this is the overall condition of the shopping center. So like the newer stores, they probably have a better rating just because their overall quality might be a little better than an older store. Access, this is the number of entrance and exit points to the parking area. And then we have our parking feature. So this has to do with the parking lot. How big is it? Are other stores sharing the same lot? How's the lighting? Is it sloped correctly? All those items go into that rating. And really quickly, we're going to just look at a couple of these fields and how they look visually. So total volume, it's very skewed, which will come up a little bit later. And then the 5 features, kind of what I expected. So somewhat normally distributed with, class 3 being the majority of the data. And then a lot of 4s. And then when we spread out from there, not a lot of 1s, not a lot of 5s. So this class imbalance is really important when we get to the deep learning models. And here we have the methodology workflow. So right now we're at this clean data step. So after receiving the data and exploring it, identifying the important fields and transforming the data a little bit. Now we have our clean data set, and we have 2 paths that we can take. The first one is going up top to the regression model. So we build a regression model from the data to predict the total volume, and then we connect that later. The other branch is the deep learning branch. So from here, number one, we need to collect aerial images of the store. So that wasn't in the data. So we have to do that. And then from there, we store the data along with the grocery store information, split the data into training, validation, and holdout sets. The training and validation sets go into actually building our deep learning models. And we're building 5 deep learning models, 1 for each of the store features. Once those deep learning models have been trained and are ready for use, we use them on our holdout data to predict the store features for that holdout group. And then we're plugging those values back into our original regression model to get an output of our predicted total volume. And from there, we can evaluate how well this whole process worked. So yeah, really quickly, I'm going to go over the regression model. So again, we're trying to predict that total volume, and we have 6 variables to do that. We're just using a regular OLS regression model. So we're going to use the area sales, and then our 5 features: visibility, traffic flow, store condition, access, and parking. I did have to normalize the total volume because of how skewed it was. That makes it really difficult to work with the regression model. So I did a log transformation to normalize the data and got a lot better results. I did end up removing 8 stores from the data set completely because they were identified as an outlier. And I'm not going to go through all the model checks, but the easiest one to go over is R squared. So at 64%, not as high as I wanted. It's reasonable for working with real world data. And at this point in the process, I deemed it usable. But I do wish that it was a little bit better. Now going down the deep learning path. So here is obtaining those aerial images. So to do that, I created this Python script that would loop through each store location, plugging into an ArcGIS API. It's called the REST World Imagery API, and was able to get some high resolution pictures out of that. Actually worked out pretty well. So here on the right, we have an example of one of the stores, the output. So I'm wanting to make sure I captured the not only the store, but the entire parking lot, the major roads that surround the store. And then to go along with the image, I also created a text file that associated with the image, and that stored the grocery store data, like the store ID and the 5 features, the total or the volume output. Basically everything I needed to know about the store was in those text files. And so, yeah, so after we did that for every single grocery store and had a nice data set of images, I was able to move on to the deep learning models, actually creating it. So to do that, I used a convolutional neural network, a CNN. This is a very popular deep learning model, and it's really good for processing images and image classification specifically. And a lot of the research that I did for like the literature review, almost everyone was using some type of CNN to work with their imagery. So I went with that. I used TensorFlow, which is a Python open source library for machine learning. So I used that framework to build out these CNN models. An important tidbit here is that I did have to resize the images actually. So originally they were 1,000 by 1,000 pixels, and I had to reduce them to 224 by 224 for compatibility and computational reasons. So I think this, I'll talk about this in the later part, but I think this caused some issues because you lose a lot of detail reducing the image size like that. The other piece here is that I had to put weights on the classes in order to prevent a bias towards the majority class. So because there were so many threes in each feature, the model wanted to predict three for basically every prediction because you get a really good output if you do that. So using weights gives more importance to like the ones and the fives to make sure that the model was actually predicting them. And from there, I did, yeah, like I said before, I split the data into training, validation, and holdout. So that was a 70%, 15%, and 15% split. So the holdout data ended up being about 1,300 images. And I also used a random seed when splitting the data to ensure repeatability and also to make sure each feature had the same splits. So yeah, here's a little example of what actually goes into the CNN training process. So here's 9 random images for the parking feature. And we can see a couple of things here. Like number one, each store ID has its associated parking score attached to the image. And you can see that there's a pretty wide range of images. And also you can see some issues here. Number one being this picture here with a lot of with a lot of shadows. That's gonna hurt the model overall, and it's hard to know how many images were like that because I wasn't going to manually go through 9,000 images to identify how many shadows there were. But so there's probably a couple more like this. And then we can also see like in the top left here, this really small grocery store. I mean, this just looks like a picture of a city block because the footprint is so small. And we see that it had a rating of a 1, so maybe that makes sense. On the other side, you can see a couple of these other larger stores that have a very large parking lot. So we have a lot of different images going into this training process. For evaluating the model, we're going to be using precision, recall, and F1. These are very popular metrics for evaluating deep learning and machine learning models, along with a confusion matrix to look at the predictions versus the actuals across all classes, and then our loss curve and our accuracy curve to help understand how well the CNN models did during the training process. And so here's continuing with that parking example. Here's what the output looked like. So on the far left here, we have the output of a single image. So this store 1081 goes into the trained CNN model, and this is an example output. So the image goes in, and the output is a confidence of each of the classes. So you can see that there's a confidence level for, parking 1, 2, 3, 4, 5. Parking 3 had the highest confidence, the highest probability. So that ended up being the prediction for this store for the parking feature. And the actual value was a 3. So this actually was a match, which is, yeah, funny because this is just a random picture that I did. So I'm glad it matched. And then looking at the other images here, so the classification report, again, we look at the precision recall and F1 score. This model had an overall accuracy of 44%, which again, yeah, not as high as I wanted. But when you think of 5 classes and you think of like a random sample, that'd be 1 out of 5, which would be 20%. So this model was better than just random guessing, which is good. I was hoping to at least hit 50% or better on these CNN models, but did get this one up to 44%. And then we can, look at each class specifically to get more details about those. And then the loss curves and the accuracy curve here, these are really good to see how the training process went. The accuracy curve did pretty good. So, during the training process, the accuracy did go up over the training periods, which is good. The loss curve, this one, I think it shows that it could be better. So we want this to decrease as time goes on. And this one did decrease, but it decreased pretty quickly right away, and then it plateaued really quickly, which means that it stopped making meaningful, it stopped learning pretty early on in the training period. So maybe with some more tweaks, we can get that working a little better, but that's what that graph tells us. So I do have later on, there's an appendix with all the graphs for all the store features, but we don't have time to go over all of them. So at a really high level, the results of the CNN models were, they were okay. So each one did perform better than random guessing, which is at 20%. But the main bulk of the data was, or I say the main accuracy of the data was the 3 and the 4 classes. Classes 1, 2, and 5 did not perform very well. The model had a really hard time picking those out. And let's see here. So if we go down to this yellow bar here at the bottom, we can see the overall accuracy of each feature. Visibility was clearly the worst, and the other ones, hovered a little bit over 40%. Parking and traffic were the 2 best features, and I think that probably has to do with the parking lots and the roads are very easily picked out from the aerial images. So I think that makes sense why they were the best. And then the other 3 were, I think, pretty obviously worse performing. And then, yeah, so at this point, now we have all the CNN models trained, and we use them on the holdout data to get a prediction of those store features for that holdout group. So for this store 54837, we plug this picture into our models and we get values 34433 for the 5 features. Plug that into our regression model, translate the output back into our monetary values, and we get a prediction of about $2.4 million predicted for that total, or for that weekly sales average. And the actual value was 1.8 million. So difference by about $500,000, which, yeah, again, wish it was a little better. It is in the ballpark, but, I was hoping to have it be a little bit more accurate. So applying this to the entire holdout group, we can kind of see the overall results of the entire process. And to get a good idea of how well the predictions did, I compared it to 2 other groups. The first group, which I'm calling the perfect values. So this would be where this would be pretending like the CNN models predicted each feature perfectly, and we plug those back into the regression model. And then we have my my predictions, and then the last group is the random sample. So that would just be randomly generating values between 1 and 5, putting them into the regression model and recording the output. So we can see from the absolute mean percentage error that the perfect values was the best as expected. My prediction was at 41%, yeah, which means that on average, the prediction was off by 40%. And then the random sample was at 44%. So it is good that my prediction was better than the random sample, but it's bad that it wasn't really that much better. And actually, it's probably worse that going from perfect values to random values was only a 4% difference. So what that tells us is that the regression model doesn't provide much benefit when trying to predict these grocery store weekly sales numbers, especially when trying to do that using the store features. And so, yeah, going to the discussion here, did the overall model work? I would say not very well. And in hindsight, I think they make sense. So from the regression model specifically, while those store features might play some role into the average weekly sales, there's going to be a lot of factors into what goes that goes into what makes a grocery store successful. So it could be, the demographics of the area, are there competitors nearby, a lot of things like that these aerial images and these store features aren't going to be able to capture. For the CNN models themselves and trying to try to predict those store features, the training data was at the mercy of these data collectors or assessors. So they could be, number one, they could be incorrect, or using different rating methodologies. So, you have one person go out to the store and maybe they record visibility and they rated a 3. You have someone else go out there and maybe they rated a 4 or 2. Even if they're using technically the same methodology, each person might have their own interpretation of that. So that is something to think about. And then for each of the store features, I think there was at least one aspect that goes into the rating of this feature, but that wasn't captured in the aerial imagery. So like, for example, visibility, the aerial images, they don't know where the front entrance of the store is. They don't know if the sign is facing the major road next to the store, if there's like a tree blocking it. So it won't be able to capture that. So that might be one of the reasons why the performance wasn't as high as I hoped. And I think every store feature has something like that. Challenges. So yeah, I'm gonna skip ahead to the CNN models specifically. Memory was a huge issue here. My computer crashed multiple times trying to create these CNN models just because of the RAM usage that is needed. So I had to reduce the batch size to help with that. I talked about resizing the images and how we probably lost a lot of detail in that. And then I think the biggest thing here was my lack of experience working with CNNs. I spent a ton of time researching, learning how to code them and how to run them. And each model just takes so long to run that it was really time consuming when trying to make like incremental changes to make the model better, and not always knowing what I needed to change to make the model better. So spent a lot of time just doing trial and error until I got something that worked. So lack of experience really hindered me there. And so in conclusion, is a automated aerial screening tool feasible for evaluating grocery store site locations? I would say yes, but it depends what we're evaluating. If you want to evaluate or predict the weekly total sales, I'm going to say no. There might be some correlations there, but not enough to provide anything meaningful or any type of accurate prediction that you can use like in the real world. But if we are going to be focusing on those store features, I do think that this method and this process has a lot of potential. So again, the accuracy wasn't as high as I had hoped, but it was better than random guessing. So that means that there was some type of learning there. And maybe with a more sophisticated model, we can get those numbers a lot better. And I'm not sure if I have much time, but yes, I have some project enhancements that I thought about as I was, kind of in hindsight here. I would have removed the regression model completely if I were to redo it, just because it didn't provide a lot of value, and I would have spent more time working on the CNN models. For the image scraper, I would have worked on a more dynamic zoom system and also build in some type of QA checks to maybe like remove those images that have a lot of shadows, like figure out a way to automate that. And then finally, when focusing on those deep learning models to better predict the store features, I would have liked to build a model for each feature specifically. So what I ended up doing was each model was its own, but it had like the same architecture. Everything was the same except for the class weights to deal with the imbalance. So building out a model specifically and changing the architecture for each model specifically, I think could provide better results. But the amount of work that would be much too long for this time period we had to work on it. And yeah, so yeah, big thanks to Jake and RetailStat for the data and the opportunity to work on this, and thanks to John for guidance as well. And yeah, so got a lot of images here. But yeah, questions, thoughts?
Tony, thank you for this. This is super detailed. I've kind of been riding with you on this journey a little bit here, and
Yeah.
Jake was able. Jake is actually in on your presentation here, so I know we just have a couple of minutes here for questions, but Jake, thanks for dropping in here. And so Jake, if you had any questions for Tony right away, that's great. If not, that's okay too.
No, absolutely, Tony. Hey, very nice job. It's awesome to see you take this data and with, kind of little direction, just a lot of kind of leaving it open-ended to explore what we can
Yeah.
do. I know we had an objective, and I was just curious to see what could be done. And it's really encouraging to see that just the way you approach this and the initial results are super interesting. And the results, the ability to correlate sales, I think makes sense, right? It's like it's kind of like you need, real estate quality will influence good sales when the trade area is right. So when there's enough people and the competitive mix is there, and then you have the hardest variable to measure, which is store operations.
Yeah.
And so it throws a lot in there. And so it's kind of like you had part of the puzzle. And I think if we gave you more data, gave you the demographics, gave you the competition, I'm sure your results would be, even, pretty impressive. And I would just like to connect with you after this, just to discuss, hey, I think the way you approached this was pretty impressive, very impressive, and how we could leverage some of this to really improve our efficiency from a desktop. We have all of our analysts going into all these stores, but there's new grocers opening up every day. There's vacant boxes every day. Retailers are constantly assessing new sites, and for us to be able to, capture, let alone grade any sort of real estate characteristic that's better than we have today in batch or just from a desktop level would be awesome. So nice job, and let's set up some time to chat about how we can start using this in the real world. It's very impressive.
Yeah, absolutely. Appreciate it. Thank you.
Thank you, Jake. Again, for all the partnership opportunities, I know there are ample partnership opportunities down the road there too with RetailStat. And
Yeah,
Jake.
absolutely. Yep.
Alumni presence here too. So
Yeah,
we appreciate
yeah, it's great.
Yep, to give back, Jake. That's pretty neat. Tony, I'll save my comments for you, but anyone else on the call here have any last or I guess kind of a question or two very brief ones for Tony? I
I
think
don't have
just
any questions, but I
yep,
think
go ahead,
it's
Heather.
great that it didn't turn out like you wanted it to, but you have ideas, and I think that your analysis was pretty thorough. So nice work.
Yeah, thank you. And it's just kind of the way it goes sometimes when you go down a research path. So yeah,
Right.
working with the real data was amazing, and these are real issues that come up when you do that. So yeah, so we learn and we build on top of that.
I also say, I'll add to that, Tony. It's exactly right. When you're doing stuff like this in the real world, you rarely get what you hope for.
Yeah.
But I think building the process is step one. The fact that you're even looking at this way and setting up the basic framework and to do this is, doesn't really exist today, at least in the retail landscape, retail analytics. And I think there's, you set it up in a way where you can incorporate so many more variables. There's a lot of ways to hopefully, maybe we can improve how we measure visibility. Let's think about what other factors could be used, measured from an aerial, to improve some of these weaker correlations that you're seeing, or the areas that were harder to understand. And so I think the big win here was, you've shown that you can improve decision making, but two, I think you've developed a way to look at it, and now it's kind of just swapping in different data points, or kind of learning how to look at it differently, which is awesome. Big win.
Yep, I agree. So yeah, it's built in a way where we can make tweaks and build on top of it and try new things. So yeah, looking forward to where we can take this.
All right. Yeah. Thank you, everybody, for your comments. And Tony, again, wonderful job on that. Jake, Tony, we can connect again after this when we get on Capstone. And so with that, Tony, congratulations to you. People are giving their kudos and hands up of applause there, Tony, for you, as well as our other presenters. So I'm going to pause the recording, and then we'll get our next speaker up, introduced, and we'll keep on marching along. All right. I'd like to introduce our next speaker, Rob Labert. Rob has focused a lot of his energies, both in school and beyond, at experiences and life, at looking at bikeability, as the title would imply. There's a really nice, colorful lead-in graphic there, Rob. It's always great to see. But looking at bikeability of school attendance zones, and we've done in the past in classes walkability studies and things like that were based on some rankings and things like that. Rob, independent of that, took this idea and really morphed it into something that is very realistic for what maybe different districts may be interested in. For everything is safety. So looking at how we can measure that and look at different utilization of resources and impediments and things of that nature. So Rob, we'll turn it over to you.
Great. Thanks, John. As John mentioned, my capstone research project was to look at the Minneapolis Public School District here, where I live in Minneapolis, Minnesota, and look at if I could develop a way to assess how bikeable the school attendance zones are. The first thing I'd like to do is address the elephant in the room. I am aware that this is not a picture from Minneapolis, Minnesota. I'm aware this picture is from Duluth. I'm looking forward to presenting this research at the Fall Minnesota GIS LIS Consortium Conference, which is in Duluth. So picture is not meant to represent the content of the research, but the context in which it will be presented. A little bit about me. I live in Minneapolis. I'm a former teacher, having taught high school math and physics for 13 years. My wife is still a teacher. I've also been a bike commuter for more than 9 years, ever since we moved to Minneapolis. However, that's a new habit for me. I did not grow up in an area where I had the knowledge or the skills or the opportunity to bike to school. And in fact, during my lifetime, my school attending years, I was in the majority, because while 40.7% of students reported biking or walking to school in 1969, that number had dropped to just under 13% in 2001 and just under 11% by 2017. All of this despite the fact that research has shown children who actively commute to school, so that would be biking, walking, scooting, skateboarding, any such similar activity, report more positive health outcomes and also report higher life satisfaction. And so this first picture here is meant to represent when I would ride my bike to school as a teacher. This is a lot of times what the bike racks would look like, just my bike. So it's my hope that maybe not because of my research, but eventually within my lifetime, we can have some more bike racks at schools that look like this instead. So this is taken at the school where my wife works. This is on National Bike and Walk and Roll to School Day. And so my hope is that I can do my little part to make less of the first picture and more of the second picture. The goal of my project was to understand some of the factors that influence active commuting to and from school, or ACS. That's a common acronym I came across in my research. After understanding some of those factors, my hope was to compile and analyze data that was pertinent to them, use that data to assign a bikeability rating for school attendance zones, and then visualize those bikeability ratings to see what insights could be gleaned. So we'll start by introducing the study area and talk about the methodology with a particular focus on the data that was used. We'll look at some results first in tabular form and then as a visual, as a map display. In our discussion, we'll discuss some sources of error as well as some recommendations for future research, and we'll wrap up with a conclusion and acknowledgements and a time for questions. So here's the study area. The state of Minnesota has a 7-county Twin Cities metropolitan area, which is shown in blue and red on the top map. The particular red county of Hennepin County is then focused in on to show the city of Minneapolis and the Minneapolis Public Schools district boundary. The school district boundary is exactly the same as the city boundary, so they are perfectly coincident with each other, and that is what that dark blue hatched area represents. So that shape, that is the outline of Minneapolis. We will see that repeatedly in the upcoming slides. Speaking of that shape, this is the Minneapolis Public Schools district shown with the 27 elementary schools that have attendance zones. So what that means is if your child, your student is of elementary school age and you live in this zone, they will by default be assigned to attend this elementary school. There are more than 27 elementary schools in the Minneapolis Public Schools district, but some of them have special purposes, such as language immersion schools, and some of them are also part of K through 8, so combined elementary and middle schools. Therefore, they do not have attendance zones associated with them. One thing to point out is that these zones are not all the same size. If you look near the south center part of the map here, the Whittier and Lindale and Bancroft neighborhoods have a lot of dense housing. So in order to get the number of students needed for an elementary school, pretty small zone. You'll notice the Kenwood zone here has most of Cedar Lake and most of Bede-Makaska in it. So again, people don't live there, so not really contributing to the population. Same with this Pillsbury zone, which is just a giant up here. If you're familiar with Minneapolis, the entirety of the mid-city industrial complex is in this Pillsbury zone. So again, not a populated area in that one. The first input data, the first data set I wanted to use to assess bikeability to school was the presence and the quality of bike infrastructure. This is a topic that I came across a lot in my research. Hennepin County has a great data set of bicycle and pedestrian infrastructure. So the first thing I had to do was query out all the pedestrian stuff. All the things that are sidewalks for walking but are not for biking were removed. After doing that, I took the remaining bike data and split it into 2 categories. Again, in my research, I regularly came across the idea of what is the quality of bike infrastructure. And the main metric I decided to use to classify the quality of bike infrastructure was separation from automobile traffic. If bikes were riding with automobile traffic in a standard bike lane or a paint buffered bike lane or simply on a bike boulevard, I counted that as good infrastructure. However, if bikes had a physical separation from motor vehicles, so literally being apart from the road, or possibly a protected bike lane with concrete curbs or Jersey style barriers, I counted those as very good types of infrastructure. You'll notice a number of these bike trails are very long. So here's the Cedar Lake Trail. going through multiple school attendance zones. Here is the Hiawatha Trail. Here's the Midtown Greenway. What I knew I needed was I knew I needed just the bike infrastructure that was present in each attendance zone. So I took all of these lines and I split them wherever they crossed a polygon. Anytime a blue or purple line crossed a brown polygon, I split it so that I could have just the portion of each bike infrastructure that was in each school attendance zone. And then of all those little segments, I calculated the length of all of them in miles. Some of them multiple miles long, some of them tiny fractions of a mile. Other theme that I very regularly came across in my research that contributes to safe or not safe bikeability is the speed of cars. Sometimes also the volume of cars, but particularly the speed. The city of Minneapolis has a data set with the up-to-date speed limits for all the streets in the city, many of which were reassigned in 2020, generally lowered speed limits across the city. In terms of querying these, just like in the last data set, I removed pedestrian infrastructure. In this data set, I removed low speed streets so that I could focus on streets who had dangerous speed limits. So I categorized bad streets as those with 40 or 45 mile an hour speed limits, shown here in yellow. And I categorized very bad streets as those with speed limits in the 50s or 60s, shown here in orange and red, respectively. I again split them at every place where they crossed a brown polygon, and I again calculated the length of each segment in miles. So now that I had all this bike infrastructure, some good, some very good, all these high-speed streets, some bad, some very bad, with all of their lengths calculated, what did I do with that data? Well, in each school attendance zone, I added up those 4 different things. How many miles does it have of each of these 4 things? The purple, very good bike infrastructure, the blue, good bike infrastructure, the yellow, bad speed streets, and the orange and red, very bad speed streets. I knew I wanted to be able to take these values and sort of amalgamate them into a final rating. However, not all miles are created equal. Is it good to just add up miles of good stuff and miles of very good stuff? Are they apples to apples or are they not? In order to help with that massaging together of the data, I was inspired by a method from Christine Prissel, who is a researcher at the University of Minnesota. In her research, she looks at urban residents in the Twin Cities of Minneapolis and St. Paul and their access to urban green space. So if it's public green space or semi-public green space or private green space. And I was inspired by her method. And so that inspired me to take these 4 sum totals and assign a z-score to them. So assuming that these sums would be normally distributed, how far above or below the mean was every value? So I got those 4 z-scores. Just as a reminder, a positive z-score implies you're above average or above the mean. A negative z-score implies you're below average or below the mean in each of these 4 categories. For each school's attendance zone, once it had all of its z-scores, I decided to add them up using essentially a weighted sum. So I knew that I wanted the good things to count positively towards the score, and I wanted the bad things to count negatively towards the score. This was another aspect that I borrowed from Prissel's method. And so I arrived at a final bikeability score for each school by taking 2 times the z-score of very good features, and then I added 1 times the z-score of good features, figuring that, well, very good stuff is twice as good as good stuff. And I did the opposite with bad stuff. So then I added -1 times the bad z-value and -2 times the very bad z-value. This gave a final score. And so these scores were what was used to kind of present a final ranking as well as a final map. And so what I did was, in pretty typical cartographic fashion, I arranged them along a color gradient from worst to best. I used a red, yellow, blue gradient. Red's the worst, yellow's medium, blue's the best. Rather than try to display 27 different colors and expect people to differentiate between them, I binned them into 9 groups. So 9 different shades only along that color ramp, and we will see those results shortly here. First, we'll look at some tabular results. I know this text is very small, so if you're interested in this data, let me know. I can definitely send you more easily viewed data. But for any given school, you can find it alphabetically on the left, and you can see the 4 sums. So these first 4 columns show you how many miles of very good, good, bad, and very bad features did it have. And the next 4 columns show you those 4 z-scores. So you'll notice if something is above average, I have the averages down here, it'll garner a positive z-score. If something is below the mean down here, it'll garner a negative z-score. I want to look at a few specific examples and just kind of show that this does truthfully reflect the features we can see from our input data. First off, I want to look at these 2 schools, Kenwood and Pillsbury, and look at how many miles of bike infrastructure they have. So you can see here that Kenwood has 10 miles of very good bike infrastructure. That's a lot. And you can see here Pillsbury has 8.6 miles of good bike infrastructure, also a very high value. If we look at the map, let's try to find those. Well, here's Kenwood over here. In this zone, look how much purple there is. There's the trails all the way around Cedar Lake. There's the trails all the way around Bede Makaska. There's the Midtown Greenway. There's all the little connecting spurs. It's easy to see how this had so many miles of very good bike infrastructure. Same thing with Pillsbury. If we look up here, the good bike infrastructure, which are those on-street bike lanes, blue segments, blue, 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 all over in Pillsbury. So it seems like our method really did do what we wanted it to do and add up those results. Interestingly enough, we're going to look at the same 2 school attendance zones and look at the very bad miles they have. Kenwood has 14 miles of very bad roads with those very high speed limits, and Pillsbury has 10.8 miles of such roads. Well, we already know where those are, so let's go back and look at the speed limits. Here we can see the Kenwood zone, which has these little ramps here to and from Interstate 394. We see parts of Interstate 94 curving around here, and even a little bit of Interstate 35W here. Lots of those high-speed roads cutting across the Kenwood attendance zone. Same thing with Pillsbury. Lots of orange and red roads, Interstate 35W, as it has a 50, 55, and then a 60 mile an hour speed limit here. So our model really does, or our method really does seem to have added up the things we wanted to add up. Those of you who like to look for extreme values have probably had your eyes drawn to Webster Elementary School down here, who has double digits in almost every category. 11 and 15 miles of bike infrastructure. How are there even 26 miles of bike infrastructure in a single school attendance zone? As well as 17 miles of very bad infrastructure. All of these values are way above the average, way above the mean. And so you can notice that Webster has positive z-scores. This is numbers of standard deviation above the mean. So 2.6, 3.9, 2.9, and 2.9 standard deviations above the mean. These are all extremely high values. Something you may or may not know is that Webster's assigned attendance zone covers all of downtown Minneapolis. So if you can see the word Webster tucked right in the middle here, every single piece of bike infrastructure in downtown Minneapolis has gotten counted towards Webster Elementary. Hence, lots of purple and blue miles of bike infrastructure. Same thing is also true with these miles of roads, 17 miles of ultra high speed roads. Yep, look at Webster right here. We've got I-94 on ramps. We've got 394 on and off ramps. We've got Interstate 94 cutting across here, Interstate 35W over here. So many miles of those roads as well. Webster is just an extreme example. And so once I saw those totals, I knew I wanted to be careful of how this was potentially going to impact my results. Speaking of results, here's sort of the big payoff. Here are my 9 bins that represent the ratings of each school's bikeability from worst, which is red, to best, which is blue. So I've got my 9 colors over here, and some really, really interesting things stood out. The first thing that stood out to me is that there are blue and red and yellow colors all over the city. There is no single part of the city that has all the red zones or all the blue zones or all the yellow zones, according to this model. Another thing that really stood out to me is that the 6 most extreme results in other words, the 3 best and 3 worst, are all in South Minneapolis. The 3 worst here, Fulwell, Windham, and Kenny, as well as the 3 best, Barton, Northrop, and Dowling, in those deepest colors. They're all south of Interstate 94 in South Minneapolis. Speaking of which, the second worst score, Fulwell here, is sandwiched right in between Dowling, which had the best score, and Northrop, which had the 3rd best score. So even proximity seems to have a lot of variability. The second worst score is sandwiched in between number 1 and number 3. I mentioned earlier how Webster was such an extreme example. All its values were off the chart. Well, by ranking 27 things in order, the 14th thing is right in the middle of the median. Webster was 1 place below that. So all of its extremes pretty much balanced out at the end of the day. This led me to start to think about a few things, what I noticed and what I wondered. There's high school scores all over the city. There's blue scores way up at the top, blue scores down in South Minneapolis. Same with red. There's Nellie Stone Johnson up there, all the way down to Windham and Kenny. So if this seems to be sort of a random pattern, what other types of questions could we answer? And so these were 2 questions that are related that I sort of wanted to see if I could gain some insight into. If there are zones with lots of high quality bike infrastructure, is there a lack of high speed streets? Or if you have more bike infrastructure, do you probably also have highways? So kind of what's the trade-off here? In other words, are there some zones where people trade car trips for bike trips? Essentially, well, there's no cars here, it's all bikes. Or there's all bikes here, it's no cars. Or conversely, are there some parts of the city where there's just more of everything? Some parts have more car infrastructure and more bike infrastructure. The other parts have less car infrastructure and less bike infrastructure. I looked closely at my results and found out that it's very clear that the parts of the city that have more stuff just have more stuff. So I'll try to tell you how I came to that conclusion as we move towards our wrap up here. What this chart here shows, this shows on the x-axis all the negative stuff. So the z-score for bad plus 2 times the z-score for very bad, all the detracting components, and all the y-axis, it has all the contributing components, the z-score of good stuff plus the z-score of 2 times the z-score of very good stuff. We have a very strong positive relationship here. The correlation coefficient is 0.87. And you can see that there's nothing in the top left. There is nothing that is like a bike utopia with a complete lack of high-speed streets. That upper left quadrant is totally empty. Same with the bottom right quadrant. There's nothing that is just like cars with an utter lack of bike infrastructure. Those 2 characteristics don't really seem to exist. If there's stuff with not many high-speed streets, it tends to have not much bike infrastructure. And if there's stuff with more and more high-speed streets, it tends to have more bike infrastructure. You'll notice that the only way to really be blue or red here is simply to try to be a little bit off of this line. If you have a little bit more positive than negative, you're above the line, you're blue. If you have a little bit more negative than positive, you're below the line and you're red. As I was thinking about all these results, a few sources of error came to mind. Is the data current? Does it reflect the actual bike infrastructure that's on the ground today? And is it accurate? If it really is a protected bike lane, is that true on the ground? If it says it's a bike-only trail, is that true in real life? Another potential source of error that I would love to think about more in the future is if infrastructure that's on the border between 2 zones should count. For example, if a student lives in the interior of the zone and attends school in the interior of the zone, it's unlikely they would need to leave their school zone or cross the boundary. So does that stuff around the edge actually have a contribution? It would be interesting to see if the results change much with that stuff removed. I definitely have thoughts of how this research could be furthered and have some recommendations for that. First is you could reproduce this for middle school and high school attendance zones. Very little would need to be changed about this method to do that. Other recommendations I would have for future researchers to consider is that not all very good infrastructure is equal. If you have a nice separated bike path that goes a really long way, maybe it has lots of intersections or maybe it has no intersections. research suggests that I came across that those are not equally good or equally preferable or equally safe. Same with all very bad. Not all highways are equally bad. If highways have off ramps that dump lots of high speed traffic into neighborhoods, that's probably not the same as highways that don't have any off ramps where the traffic has no way to actually access into that neighborhood. Lastly, far and away, my greatest recommendation for future research is to be able to compare this model and these predictions to the actual rates of students biking to school. I reached out to the active living coordinator at Minneapolis Public Schools, and they told me that this data is not collected. This data is not aggregated and does not exist. And so if I had an immediate thing I could do next, it would be to figure out a way to gather this data to sort of test out my predictions against reality. So to cycle back to my goal for this project, it certainly is possible to use publicly available and open data to develop a bikeability rating for the Minneapolis Public Schools elementary attendance zones. However, there's lots of opportunity to refine this model, apply it more broadly, and I would say most critically, compare it to actual rates of biking to school. There are a few acknowledgments I would like to make. Definitely, I could not have done this project and this course without Dr. Ebert and the rest of the St. Mary's faculty. Thank you to them. Also, thanks to Heather Hagee and Kelly Chorba, who have given me some of my full-time opportunities to make a career change into the GIS world. I also want to thank Eric Sauer and Sophia Spizak, who are my coworkers and who have borne with me and joked with me and helped me personally just kind of get through a lot. And also, most of all, to my wife, Stephanie. Definitely could not have done this without her. Grateful for her companionship and her support every day. With that, I will present these sources here. If you are interested in these slides or the data behind them, feel free to contact me. I'd be glad to share them with you. And I would love to field any questions that people might have.
Yeah, Rob, you and I and Ms. Angela will work together on your comments in your paper. So I just wanted to offer up a general delivery comment that it was very clear to me that you spent a lot of time on the presentation, very succinct, spot on, very clean communication. So congratulations to you on that. Your topic's super relevant as well, especially in the world of the true kind of GIS core. When we think of GIS, we think of things like this that relate, and many of us in our projects, we have things like that, but yours certainly is a great definition of that, really getting into the spatial world there, so to speak. And so congrats to you on the delivery, the presentation, appeal, very, very nice. Any questions from folks joining us here live this evening? We have a couple minutes for questions here. For Rob, I'll save mine for the paper, and thank you for submitting that. I have that in the folder there.
Yeah, Tony here. I got a quick question. A really great job, Rob. This was super interesting. How easy or maybe how difficult do you think it would be to translate this same methodology to a different area, like how could you look at St. Paul? Is it a lot of it coming from the same data source? Would you have to reach out to different sources to do that, or to kind of expand your research?
Yeah, that's a great question. With the specific data I used, I can confidently say that I need 3 different answers to answer your question. Regarding the schools data, that schools data I got from the Minnesota Department of Education. So any school district in Minnesota, I could find their elementary school attendance zones right now. The bike infrastructure data is maintained by Hennepin County. So any school district in Hennepin County, I already have the bike data ready to go for. I do know that Ramsey County maintains a similar data set. My suspicion is that as you leave the metro area, the municipal level of bike and ped GIS data drops off.
Yeah.
And then with speed limits, I think the main thing, I think you can get them from a lot of sources, from probably US DOT all the way down to something like OpenStreetMap. I think the main thing with speed limits is you'll want to make sure they're accurate, that they reflect what the speed limits actually are, current and up to date on those streets.
Sure. Awesome. Thank you.
I'll just make a comment on
Yep, go ahead,
relevance.
Ms.
I know you said it's relevant to the GIS industry, but it's also relevant to transportation, just working in transportation. It's a constant every year. There's more and more biking facilities that are, or there's more of a need for it and more of a desire for it. So having a way to, I think, choose candidates for where bike facilities should go. This is in line with that. And a lot of places just kind of pick it by like attendance and I don't know, kind of your good road, bad road scenario. Like, do they, do we need a concrete barrier? Do we need, is there high speed? So we want to make sure people are safe. So yeah, it's very relevant.
Thank you.
Yeah, great comment as well. Any other final comments for Rob? Otherwise, Rob, congratulations to you. Super congrats there. I know you'll be presenting
Thank you.
at the conference as well there. So hats off to you on that. And again, everybody is in some way giving you, Burhan and the others are giving you a big clap and applause there, Rob. So congrats to you on that. And we'll get our next speaker up going here in very, very quickly. So we'll be right back. I'm just going to pause the recording. All right, everybody, welcome back. We have our next presenter, Faisal, up to present some, it's a different way of thinking about GS utilization, but more on a larger scale. And Faisal's journey also started off with examining, here, what are some statistical things? What are some geoanalytical based predictive insight that both GIS and statistics can use to predict, what's going on with voting and in democracies, and can this technology be used to predict some type of a democratic type of collapse? That has a lot of different definitions, connotations there, but Faisal, I'll let you explain as you take it away and share a little bit about what you found with your topic. So we'll turn it over to you, Faisal.
As Mr. John said, my name is Faisal Gedi, and today I'm going to present my capstone project titled Using Geoanalytics to Predict Democratic Collapse in Africa. My research paper focuses on how geoanalytics can be used to understand and predict the fall of democratically elected governments in parts of sub-Saharan Africa, specifically for these countries, Guinea and Burkina Faso. I have chosen this topic because democratic stability is crucial for development, and there is an urgent need to identify early warning signs using modern data-driven methods. Let's begin with an overview of the problem and why it matters. I think I have made my introduction. Okay. In this project, I explore how geoanalytics, that is the use of geographical data tools, can help us better understand and predict when and where democratic governments may collapse in sub-Saharan Africa. I specifically focus on two countries, that is Guinea and Burkina Faso, which have both experienced recent democratic breakdowns. This project integrates multiple data types, spatial data, conflict event records, governance indicators, and electoral participation trends. By combining these sources, I was able to identify geographic patterns such as hotspots or violence areas, extremely low and voter turnout that could act as an early warning sign of democratic erosion. This type of analysis provides more visual and predictive approach than relying on political commentary alone. It's about using data to anticipate and ideally help prevent future collapses. A little bit, just excuse me. Okay. So in my methodology, are you all in my methodology? I think. So in my methodology, I'll explain the tools and techniques I use in my analysis. I primarily relied on spatial analysis using ArcGIS and chart-based visualization using Microsoft Excel. These tools helped me to analyze and communicate patterns in a clear, visual way. I created maps to show difference in governance and voter turnout across regions and hotspot maps to highlight areas with high conflict and or protest activity. I also analyzed voter turnout and protest intensity at the regional level to understand where democratic participation was declining and where unrest was growing. My mapping layers included several types of data governance indicators, conflict reports, and measurable of institutional trust. Combining these data sets allowed me to observe where democratic erosion was more likely to occur. So in this slide, I'll outline the structure of the workflow I used to prepare my data for analysis. First, I acquired data from multiple sources, including governance reports, protest, event datasets, and election data specific to Guinea and Burkina Faso. Then I cleared and formatted the data to ensure consistency, removing duplicates, correcting errors, and organizing fields for data analysis. The third step was to geocode and project the data, which involved assigning geographic coordinates and converting all spatial layers into a common coordinate system compatible with ArcGIS. After that, I normalized and scaled the data. This allowed me to compare variables like protest frequency and voter turnout on an equal footing, regardless of region, size, or population. Finally, I have integrated the clean and prepared dataset into ArcGIS, where I created my map, hotspot analysis, and composite indicators to detect patterns of democratic erosions. So in my key findings, here I'll present the major insights derived from the spatial and statistical analysis. First, I observed that low voter turnout and limited institution trust were geographically clustered in regions already known for political instability or occurring conflict, such as parts of northern Burkina Faso and eastern Guinea. The spatial layering approach allowed me to identify a temporal alignment between unrest and institutional fragility. In other words, periods of heightened protest activity were often preceded by signals of eroding governance capacity or declining voter engagement. These geographic patterns were not just coincidental. They reveal the vulnerability zones where multiple risk factors coexisted. This will have been difficult to detect without combining spatial and non-spatial data. Finally, ArcGIS proved to be a powerful tool. It revealed a subtle spatial dynamics that were not apparent from raw tables or chart alone, showing, for example, that some protest hotspots were located near administrative boundaries, which might reflect contested jurisdiction or weak state presence. If you look at this slide shows a comparative analysis of voter turnout and trust in elections over 3 election cycles, 2020 to 2015 and 2020 to 2015 and 2010, 2015 and 2020 in both Guinea and Burkina Faso. As we can see from the chart, as you can see from this, there is a clear downward trend in voter turnout. If you look at the trend, there is a clear downward trend in the voter turnout in both countries. Guinea starts off slightly higher than Burkina Faso in 2010, but both show consistent decline. More importantly, the dotted lines reflects level of trust. The level of trust in elections also showing a significant erosion over time. This indicates that citizens were not only turning out to vote less frequently, but also losing faith in the fairness and integrity of the election process. These indicators, declining participation and trust, are often early warning signs of institutional fragility. In the context of this project, they help explain why certain areas are more vulnerable to authoritarian backsliding or democratic collapse. This visualization was created using Microsoft Excel, while regional mapping of turnout was done in ArcGIS to explore spatial variations, some of which align with zones of protest intensity. For this slide, if you look at it, it provides a longitudinal view of the voter turnout in Burkina Faso and Guinea. The graph shows a steep and a consistent decline in both countries over the past decade. In 2010, both countries started relatively high, with relatively high participation rates, around 65%. However, by 2022, turnout had dropped significantly to below 45%. This consistent downward trajectory signals a growing disengagement from democratic participation. In the context of this study, declining voter turnout is not just a civic issue, it reflects deeper erosions in trust, legitimacy, and institutional performance. The loss of confidence in political processes and repeated election-related instability contributes to societal fatigue, particularly in rural and conflict-prone regions. These trends were not just visible in numbers. When mapped, especially using ArcGIS, areas with sharp and turnout declines often overlap with zones experiencing high protest frequency, civil unrest, and military interventions. These findings suggest that the turnout metrics can be and act as an early sign warning indicator for potential democratic collapse, especially when combined with spatial and institutional data. If you look at this chart illustrates the governance effectiveness for Guinea and Burkina Faso from 2010 to 2020 based on World Bank worldwide governance indicators. Throughout the decade, Burkina Faso consistently outperformed Guinea, maintaining higher governance effectiveness scores, while both countries experienced some fluctuations. Burkina Faso government remained relatively stable, both above the regional average. Guinea, on the other hand, however, hovered at a lower levels with only modest improvement. Governance effectiveness measures the quality of public services, civil service independence, policy formulation, and implementation credibility. In Guinea, persistent institutional weakness, political volatility, and frequent reshuffling of administrative leadership likely contributed to the lower score. In Burkina Faso, although through governance was more consistent, effectiveness began to plateau after 2017, which coincided with the growing insecurity in the northern and the east part of the country. This stagnation will later contribute to public dissatisfaction and eventual instability. When mapped spatially, lower governance scores in specific provinces align with the areas experiencing protest activity and electoral mistrust, as revealed through ArcGIS layering. These patterns emphasizes that declining governance effectiveness, especially when localized, can signal deeper institutional erosion and heighten the risk of democratic backsliding or military interventions. If you look at this map highlights the geographic distribution of governance effectiveness in Guinea and parts of Burkina Faso between 2018 and 2023, using spatial overlay in ArcGIS. The shades of green represent governance effectiveness scores by administrative region. Darker green shades indicates stronger governance, while lighter shade reflects weaker state capacity and institutional fragility. As seen, as much of Guinea falls within the lower effectiveness rate 0.4, from 0 to 4, especially in northern and central zones. The red circle shows protest events, locations, and intensity, with larger circles representing more frequent or intense unrest. These protest clusters align spatially with areas exhibiting lower governance scores, and particularly around Conakry and the surrounding regions. These spatial correlations suggest that areas with weaker public institutions, reduced services delivery, or corrupt local administration are more vulnerable to public dissatisfaction and mobilization. Notably, Burkina Faso shows higher governance scores, especially in the southeastern and central provinces, and correspondingly fewer protest events, reinforcing the relationship between institutional strength and political stability. In this slide, it presents a comparison of key socio-economic stress indicators. Youth unemployment, poverty rates, and food insecurity in Guinea and Burkina Faso, offering insights into structural pressures that may contribute to political instability or regime collapse. Starting with youth unemployment, Guinea shows a significantly higher rate compared to Burkina Faso. Youth unemployment is a critical metric in a fragile democracies, as delusioned young people are more likely to disengage politically or participate in unrest, especially in urban areas with limited economic opportunities. In terms of poverty, both countries report high levels, with Guinea slightly higher. Over 40% of the population in both countries live below the national poverty line, reinforcing chronic underdevelopment and citizens' dissatisfaction with the government performance. Lastly, food security, while prevalent in both countries, is marginally higher in Burkina Faso. It's marginally higher in Burkina Faso. This particularly concerning, given its link to climate vulnerability, rural displacement, and conflict over land or resources, especially in regions having or facing a violent extremism. Collectively, socioeconomic pressures contribute to the erosion of state legitimacy. When combined with weak governance and political exclusion, they act as an underlying driver of protest, migration, or even coups. Understanding these indicators help us recognize which stress points to monitor when predicting future democratic collapse in fragile states like Guinea and Burkina Faso. Limitations. While this project has revealed meaningful spatial and temporal patterns of governance failure in Guinea and Burkina Faso, it's important to acknowledge the limitations that affected the scope and the depth of my analysis. First, I encountered data gaps and even data quality, especially when working with governance and protest event layers. In several cases, subnational datasets lack uniformity in scale, resolution, or temporal coverage, which impacted the clarity of some visual outputs, particularly for areas outside capital regions. These constraints reduce my ability to generate consistent hotspot density comparison across all districts. Secondly, the lack of real-time or near real-time data prevented the incorporation of dynamic forecasting methods. This was especially relevant for modeling sudden regime changes or coup risks, which often evolve rapidly in volatile environments. Had real-time protest monitoring or updated institutional scores been available, we could have built more responsive models. Lastly, while these predictive modeling techniques such as logistic regression or survival analysis are considered during planning, I have not implemented them due to time and data limitation. These models will have enhanced my ability to quantify the risk of democratic collapse under various scenarios. This remains a critical area for future research or system extension, particularly for early warnings frameworks in fragile democracies. Based on the findings and the limitations of this Capstone project, I propose three core recommendations to improve the accuracy and impact of geoanalytical studies on democratic collapse in West Africa. First, we need to improve access to up-to-date data, up-to-date and granular spatial data sets, which particularly those related to governance, protest, and institutional performance. Much of the current data is either outdated, aggregated at national levels, or inconsistently reported. Creating partnership with regional organizations and civil society for ongoing data collection will enhance both the spatial and temporal resolution of our risk assessment. Secondly, future iterations of this project should implement machine learning models such as decision trees or ensemble methods to enhance predictive capacity. Unlike static mapping, these models can process large volumes of time series and spatial data to detect complex patterns and thresholds associated with governance breakdown. Integration of these techniques will transform these from a descriptive analysis into an early warning system. Finally, it's essential to integrate community-level data into the analytical framework. Local-level insights on the things like informal governance structures, economic grievances, or security dynamics are often overlooked in top-down data sets. Yet these factors are crucial for identifying localized democratic vulnerabilities that may not appear in national indexes. Overall, these recommendations can strengthen the project's contribution to conflict prevention, political monitoring, and humanitarian planning in fragile democracies like Guinea and Burkina Faso. So in my recommendations, in my acknowledgements, I would like to extend my deepest gratitude to the individual and institution who made my research paper possible. Firstly, I want to thank the lecturers of St. Mary's University, that is Mr. John Ebert and Ms. Ambo, for their feedback and instruction in GIS, data science, and research design, and the foundation for this paper. Secondly, I also want to acknowledge the contribution of my friend Abdulaziz, who has been instrumental support in helping troubleshoot technical issues and clarify critical methodology decisions. Lastly, I would like to recognize the values of community providers and open data access platforms. ACLED, Afroperimeters, and World Bank responsibilities these provide will not have this paper will not have been possible without them. In my conclusion, did I leave my?
Yep, no, that's great there, Faisal. Thank you very much for that. And as with Rob, just wanted to offer up a very, very global comment on, it's very clear you rehearsed and prepared your presentation very well. And it was also fun to see your acknowledgement of Abdulaziz. We remember him very recently here as well. So it was nice to see him sort of coming back virtually there too. But papers, we're working on those. Obviously, I'll save my comments for the papers, but anybody who's in attendance, any questions for Faisal?
I had a question about the government effectiveness score. You might have said that and I missed it, but did you create that score based on certain factors? Or was that data that you found?
That's the data I found.
Okay.
Yeah, it's not real time.
Okay. Very interesting data. I like the idea of this project.
Yeah, there's like the diversity of topics. Ms. Hamza. Yeah, it's what really surprised me about these. Rob, did you have a question?
Yeah,
ahead.
Faisal, similar to Miss Amswell, I just had a quick question about the data you found. Did you find data available for lots of countries in Africa, or really just these two countries?
I found a voluminous data for many countries. As you know, there have been successive regime changes in Africa, about 8 to 9 countries. So I have narrowed down my paper to 2 countries because the data would have been broad and the paper would have been too huge. So
Mhm.
following on the advice of Mr. John, I narrowed down to 2 countries only.
Yeah, great, thank you.
It's always easier to focus on a couple, Faisal, than it is maybe a ton of different things. So then we get grounded and can focus on, an area or two. Any other comments for Faisal? Otherwise, Faisal, thank you very much. We'll be saving, well, we're not saving them intentionally, just for time, that we'll drop some other commentary into your paper as those come forward. So you can go ahead and end your screen share there, Faisal, and we are all giving you a virtual applause here from everybody. Burhan is clapping for you. Burhan will be up here in just a minute. And so with that, we'll transition, Faisal, from your presentation. Again, wonderful job. And we'll move on to our next presenter. So I'm just going to pause this and then we'll get our next presenter up. So, all right, everyone, welcome back. Our next presenter is Vishnu. And correct me if I'm wrong, but is it Tariqa?
Tariqa, yeah.
Tariqa, okay. Well, I'm working on my names there, so I'll need a little time yet to get that right, Vishnu. So anyway, welcome, Vishnu. Vishnu is presenting her work with really another cool application. These are some global, some small scale, some bigger scale, but this one's looking at wetlands, and really a great classic change detection type of an application between the years of 2015 and 2024. So a little bit closer to modern or almost present with that. And so Vishnu, a lot of exciting stories in here. We will turn it over to you.
Thank you, John. So, good evening, everyone. My name is Vishnu Tariqa Balaji, and I'm honored to present my capstone project titled The Disappearing Wetlands of Chennai 2015 to 2024, a GIS-based analysis. This project focuses on how Chennai's wetlands have declined over the last few decades and how GIS-based methods and satellite imagery can be used to map, quantify, and communicate these changes. Chennai is a major metropolitan city that is located in the southernmost region of India. With long coastlines and tropical climate, the city is uniquely vulnerable to both flooding and drought. This makes its wetlands extremely important. Now let's move on to get to know more about wetlands. Wetlands are one among the most valuable ecosystems in the world. They act as natural sponge, absorbing excess rainwater during monsoons. They recharge groundwater and improve water availability. They filter pollutants and enhance water quality. They also support diverse flora and fauna. Historically, Chennai was known as the city of lakes. It has n number of lakes, but over the past few decades, unregulated urbanization, poor land use planning, and encroachments have led to rapid wetland degradation. Over here, I'm sorry about that. Over here, there is a map of Chennai. This is a map of Chennai in the year 1970, and this is the map of Chennai in the year 2010. The gray region represents the wetland. In the 1970 map, we can see that almost 85 to 90% of Chennai was full of wetlands, and in 2010, we can see that it has degraded a lot. This is one of the reasons why I chose to do this project. Moving on to purpose and research. The objective of this project was to analyze how major wetlands in Chennai changed in surface area between the year 2015 and 2024. My approach was to use SD Wayback historical imagery and manually delineate these wetland boundaries for each year. and further calculate these areas annually, and then use some statistical tools to further analyze the severity of these losses. Ultimately, this work is intended to raise awareness about Chennai's environmental fragility. Moving on to study area. So I focused on 10 major wetlands, which we can see over here, namely Pallikarnai Marsh, Chembarambakam, Ambattur, Retteri, Pural, Valacheri, Korattur, Villivakam, Perangudi, and Chittalapakam lakes. These lakes were selected based on their size, ecological value, and their urban impact. So almost all of these lakes are situated in between rapid developing areas. So this is my workflow. This workflow is like totally of 6 steps. So firstly, I acquired the satellite imagery from Esri way back. Then I set up a ArcGIS Pro project with a geodatabase where I organized all the imagery year-wise. And I also created a feature class for each year. And after that, I started delineating the wetland boundaries annually, and I calculated them into acres, and I exported the table further to Excel for further analysis. I'll explain all of this in detail in just a minute. So as I mentioned earlier, I got the satellite imagery from Esri, and I made sure that the imagery was cloud free and visually clear. And the tool I used was ArcPro, and I created the geodatabase. This is an image of the geodatabase, and this is the image of the content panel. This is how I organized all the 10 years. I also created bookmarks for all the 10 lakes just for easy access. Once that was done, I used the editor tool and started delineating these wetland boundaries. I delineated 10 wetland boundaries for 10 years. So I came up with 100 polygons. And after that, I used the calculate geometry tool, as shown over here, for converting the area into acres. After that, I exported my attribute table to Excel. This is how I did it. I mentioned that over here in this picture. Once I exported my attribute table in Excel, I cleaned and structured all of my data. And then I calculated the annual changes and the cumulative loss over like 2024 versus 2025. And also I ranked the loss by percentage. And I also created few pivot tables. And for visualization purpose, I created a bar chart and a line chart. So yeah, this was my bar chart. The bar chart shows total wetland area across the 10 lakes per year. With over here, we're able to see that 2022 has seen the worst wetland loss. Next this is my line chart. This shows individual lakes trend. Like we can see here, this is Chembarambakam Lake just over here, how much it has declined, but it has, also seen recovery. It's slowly recovering after 2023. Same over here, this is Pural Lake. And here is Pallikarnai Marsh, one of the biggest wetland of Chennai. We can see how drastically it's been degrading. The decline is pretty steep. So these are individual lakes trends. And this is the percentage loss that I calculated using this formula. As we discussed earlier, Pallikarnai Marsh has seen the worst degradation of all. Following that is Retteri Lake. And next is Korattur Lake. So we can see over here, Retteri Lake is pretty stable, but towards the end, it's seeing a steep decline. That is what is shown in this table. Yeah, I also calculated the total area in acres. So this was the total area, like all the 10 lakes combined. In the year 2015, the total area in acres was 13,000, but in 2024, it declined to 11,000. Almost 2,145 acres were lost, or in other words, almost 15.5% wetland decline is being seen. And I used this particular formula to calculate the acres. Moving on, to demonstrate a year-wise boundary shrinkage, I included a time series overlay map of Chambarambakam Lake. It showed progressive shrinkage, but as I mentioned earlier, it also showed some recovery. So that's why I chose this lake. And here we can see each year. This is how I delineated all the year, one by one. And we can see that the lake, it has shrinked a lot, but towards the end in 2024, it also recovered its land area pretty much. Moving on to discussion. So urban expansion has been one of the primary focus that is driving this degradation of Chennai wetlands. Most of the affected wetlands lies in between the most developing areas. For example, Pallikarnai Marsh, which was once a vibrant and ecologically rich wetland, it is now a landfill, a residential complex, and a commercial developing area. While I was delineating Pallikarnai Marsh, I actually saw a road was built in between the marshland. I am from Chennai, so I've also seen that. I've been on that road, so I can see the wetlands on both the sides, and I'm on a road in between. So these are some of the reasons why these type of important wetlands are degrading. These commercial areas are slowly eating up the boundaries of these wetlands, and this is what caused these kind of disastrous situations. So over here, I have another map of Chennai. This is from the year 1980, and this is from the year 2010. The red region resembles the build-up area. You can see here in 1980, this was the overall build-up area of Chennai. But in 2010, it pretty much spilled over all the regions of Chennai. And here you can see this tiny little region over here. It's slowly starting to take over lakes and wetlands. And this picture clearly explains that situation. Moving on to environmental implications. So this continuous wetlands has triggered some serious environmental issues. Chennai has been facing some serious flooding issues since the year 2015. Almost every year, Chennai is facing flooding issues. And here there are some of the images of these flooding, and it's pretty serious. One of the major reasons, according to many articles, is wetlands. As I mentioned in the introduction, wetlands act as a natural sponge and absorbs excess rainwater. When these type of wetlands go missing, the excess rainwater has nowhere to go. That is one of the reasons why these kind of flooding is caused. And another reason why is there are some build-up areas that are built on like the natural drainage system, like rainwater needs to go merge into the sea. And there is a natural drainage system in Chennai with the help of wetlands and lakes, of course. And those natural drainage systems are blocked by residential buildings. So these are the reasons why Chennai has been facing some serious flooding issues. And not just that, Chennai has seen a decline in groundwater. And all of this has led to heat stress and water scarcity. Okay. Moving on to limitations and recommendations. So while the findings from this study is significant, it is important to acknowledge the limitations. First, it only focuses on 10 large wetlands, excluding many other wetlands that are present in Chennai. if we include all of those wetlands, we can get a different story, or maybe a very serious one. Second, I manually delineated these wetlands, and although I did it very carefully, it does have some level of subjectivity. So that is the second reason. And additionally, this analysis only assesses the surface area loss. It does not include any rainfall data or any land use data or any other build-up data. Once we include all of these data into this type of project, we can come up with more meaningful insights. For future work, I recommend integrating urban growth data, rainfall trends, and other hydrological layers for more accuracy. And if possible, adapting a AI or a machine learning model can give more accurate results. Instead of manually delineating each and every wetland, if we use AI, it could give more precise answers. So, conclusion. So to conclude, over the past decade, Chennai has lost, as I said, almost 2,100 acres of wetland, and some lakes like Palikarnai Marsh, which is one of the biggest wetlands in Chennai, has been seriously affected. And using GIS tool and such as ARC Pro and Esri Wayback Imagery, I was able to map, quantify, and visually demonstrate this pattern of ecological loss. These visualization communicate the situation clearly. And the finding of this study provides compiling evidence for Chennai's planning authorities and urban developers and environmental advocates. The strong conservation policies, especially those tied to land use zoning and encroachments and wetland restoration, is extremely important at the moment. I have read few articles where government did take some steps and is continuing to take few steps to protect these wetlands. It has been it is being closed to public. It is, some wetlands are said to be forest areas, and government is doing its part. I've read an article where it said government has spent almost 13 billion on these wetlands. I'm not sure, I need to check, but yeah, government is doing whatever it can, but I don't think it's enough yet. There's still a lot more that is need to be done. And preserving what remains of Chennai's wetland, it's not just the environmental ideal, it is essential for cities' resilience. In the face of climatic change and erratic monsoons and rapid urbanization, these wetlands act as a natural safeguard for millions of residents in Chennai. So I feel Chennai's future do depends on these type of ecological sites and these type of wetlands. So yes, that is my conclusion, and this is my reference. These are all the articles that I refer to. And yeah, thank you all. I would like to thank my professor, Dr. Ebert, and Ms. Hamsbergs for guiding me and supporting me throughout. And I would also like to thank my husband and my parents for supporting me. Thank you.
Thank you, Vishnu. Yes, this again another really insightful topic here that kind of goes with the theme of everything that we've been looking at here. Can you comment for us the role of literature and how that helped advise your, I'll call it your plan, your approach, your methodology a little bit on that?
So literatures were really helpful. Firstly, because I had satellite imagery and data for like years after 2015, but I wanted to understand the exact situation of these wetlands. So these the images that I showed you earlier, Chennai's map of the year 1970 and 1980, those type of maps were acquired from those type of literatures, and the literatures explained how these degradations started. that was very important to me. So with those insights, I followed up on similar set of wetlands that the research also, focused on. So in that way, I was able to structure my methodology and I was able to structure my project on whole. So that way, I think the literature really helped me a lot.
Yeah, literature is such a guide, in class and what we do in research classes. One of the best formative assessment opportunities out there is to connect with literature. Formative means, in a sense, grounded in development of your approach, that you're formative or forming. And summative is more of an ends-based type of assessment where you're looking at, summary, statistics, field checks, verification, all that. But perhaps the greatest example of a formative assessment opportunity is to ground your methodology, ground your rationale, ground your data types, your data acquisition, the process, procedures in literature. So oftentimes it's used to help guide a question, of what it is that you're trying to do. You remember that question of what is it that I want to know? And if we get down a path where we're not sure, literature can help shape that direction to know if there's additional gaps or other opportunities, but give us a sense of if we are on the right track. And so then when we assemble our methodology, we assemble our data, we have all the pieces for that.
Yeah.
So yeah.
Yeah, as you said, I think it acted as a guide. Like every other time I was working on my project, I was constantly going back to the literature. I was saying what happened at that point of time, how they, how their methodology was structured. And that kind of helped me with mine.
Most definitely. Yeah. So thank you for that, because it's often literature that is often the quiet form of assistance out there.
I agree.
Good. Other questions, comments for Vishnu that anyone may have? Rob, Samsba, anybody? Rob, go ahead.
Yeah. Hi, Vishnu. Yeah, I really enjoyed your presentation, especially I know with working at Geospatial Services, you're well experienced in manual delineation of polygon features. I was curious if you were aware of any areas of Chennai or maybe in similar areas where perhaps due to flooding or sea level rise, are there developed areas in anywhere that you know that are returning to being wetlands, that are maybe being abandoned or undeveloped, so to speak?
Not really, actually. Chennai is rapidly developing. So every empty space is being developed into a mall or a theater or a IT park. So I haven't seen any ecologically important place that is built or was planned to build, or it was never restored, or that never happened in Chennai. I'm from Chennai, so I can say that for sure. But I think government is taking measures towards it. What I saw recently in an article, I think I included that on my reference, I'm not sure, but one of those articles, once a wetland, there was once a wetland that was tried to convert into a commercial site, but the government, what it made was it created it into a recreational center, like into a wetland park. They called it Sponge Park, if I was right. So that was something new in Chennai. It's been 4 years since I left Chennai, so I haven't seen that in person, but it was very interesting for me because government did take a step towards preserving what is left of the wetland. And I really liked the idea of sponge parks. So the government is trying to build more of them. In that way, they preserve the land and also kind of develop the city in a very aesthetic way. So yeah, I hope I answered your question.
Yeah, definitely. Thank you.
Thank you for the question. Yeah.
Other questions for Vishnu? Okay, well, Vishnu, we are kind of getting back to where we are here for our time. So we're sitting good on that, but we'll continue to, between Ms. Amzo and myself, we'll get you your comments back in your paper. I know those are in play right now for everybody. So look for those to come back within, the next week or so. We have a couple of weeks to work on those. So once again, congratulations to you. This is a great achievement for us all here, as I was saying earlier. So appreciate all the time and energy you put into your presentation, the photos and graphics always help give us a little more of an excitement, of an appeal, relating to our topic. So thank you very much for that.
Thank you.
And so I will pause our recording and we'll get our next person up and ready to go here. So you might have to end your screen share, Vishnu. Welcome everyone to our next presenter, Burhan Hassan. And Burhan also has another application. I love the scale. That's kind of a cool theme. We have different parts of the globe. We have different parts of projects and scale and whatnot. But Burhan was studying obesity and kind of really some causational relationships between obesity, life expectancy, but yet really looking at this relationship on a state level, kind of a summative or a descriptive type of statistical application in the United States here. So Burhan, whenever you are ready, you can take it away.
Hello everyone, my name is Burhan Hassan. Today I will be presenting my capstone project with the title of Obesity and Life Expectancy, a state-level statistical analysis in the United States. So jumping over to the next slide, on the purpose or the introduction of my project, the main goal of this study was to find out if obesity is connected to how long people live in different United States. We know that obesity is a health problem, but I wanted to see how it might affect average life expected at a larger scale by state. Also, I used state-level data to explore this relationship and tested it using simple statistics in Excel. On the background of my topic, more than 40% of US adults are seen to be obese, and obesity is linked to serious diseases like heart disease, diabetes, and even cancer. In some states, we are seeing people live shorter lives, and my study asked, could obesity be one of the reasons for this difference between the states? States in South and Midwest, for example, tend to have both high obesity and lower life expectancy. For the methods and design that I used in my project, I actually collected data from two trusted sources. One of them was Centers of Disease and Control and Prevention for obesity rates, and the other source was US Census Bureau for the life expectancy. Also, these numbers are average for each state, and I also used, like I said, simple Microsoft Excel to carry out the cleaning of the data, prepare for analysis, and carry out the outcome or the finding. As you can see in the next slide, it shows the data with states, all the 50 states, then obesity rate in percentage, life expectancy in years. And we'll see how it develops as we go on. And this also shows the work overview, where I started from data acquisition, cleaning, then carry out the correlation, visualization, then we're gonna talk about the interpretation of the whole thing. Moving forward to the methods, I used three main steps to analyze the data. One of them was descriptive statistics to understand the average obesity rate and life expectancy. The second was correlation to check if there's a strong connection between the two variables. And the third one was linear regression, to create a model that shows how much life expectancy drops when obesity increases. As you can see, the equation right here, it says life expectancy. It means that if obesity goes to 1%, life expectancy goes down by about 0.48 years. And for the results, my findings showed a strong negative relationship between obesity and life expectancy, where the R square value was 0.8%, which means that about 81% of the difference in life expectancy can be explained by obesity, which is a strong relationship when you see the 81%. For example, states like Mississippi had a higher obesity rate and short life expectancy. If we can go back to our data table, you can see I use the red lines to show the Mississippi right here. It has a higher obesity rate and a lower life expectancy rate. Also in Hawaii, states in Hawaii had a lower obesity rate and longer life expectancy. Also, we can see this one in our table where Hawaii has 25% obesity rate and 81.6 years in life expectancy, which makes the state with the low obesity and long life expectancy among the 50 states. For this one, the outcome, when I run out the data in Excel, where you can see the mean, and also here the maximum was 25%, and I discovered this, the minimum was 25%. I discovered this was the Hawaii state, and Mississippi also was 73, where maximum was also West Virginia. You can go back to our chart, we can still see West Virginia had a 40.7%. And this was the summary output of all the statistics in the Excel. Also, this figure shows the scar plots with regression line for obesity and life expectancy. The next one was histogram of obesity rate, where you can see the obesity rate on the y-axis, on the x-axis. And the next one was histogram of life expectancy, which clearly shows how it spread all over the number of the states. The other thing was box plot of expectancy rates, where I get it from the Excel. It also shows where the data is spread over the states compared to obesity rates. For discussion and interpretation for this topic, this result matches what we see in national health trends mostly, where obesity is also known as, we also know that obesity is also known as health risk, and this project shows that it's also linked to how long people live. However, my study does not prove that obesity directly causes shorter life expectancy, which I will say is a limitation of my topic. Also, there may be other factors involved like income, healthcare, access, or education that maybe can affect this study. And I think I didn't talk about that one, which also I think is a limitation of my topic too. Still, this strong relationship gives us a reason to pay more attention to obesity in public health planning. Here we go for limitation and recommendation for this topic. I only looked at variables like obesity and life expectancy, like I said. I didn't look for other factors like income, education, health access, and also the obesity data was self-reported, which might be slightly inaccurate. I would recommend in the future adding more variables like income, or maybe smoking rates, or healthcare access, or doing multivariable regression to get a fuller picture of this topic. To conclude, obesity is a strong predictor of life expectancy at the state level. This means that reducing obesity could help people live longer. Also, we can use simple tools like Excel to carry out the data for useful public health analysis. And this research can help decision makers create better policies focused on reducing obesity and improving healthy care or health planners. To acknowledge, I would like to thank Dr. John and his Heather for always supporting and feedbacks, comments from day one of the class to the day to day. Thank you so much. I also like to thank my classmates for taking through this class, making also some feedbacks. Thank you so much. Also, thank to my friends and family for their continued support throughout my education. And yeah, thank you so much, everyone.
Thank you, Burhan. Yeah, that's appreciate the acknowledgments there. And, you know, you left a lot of good comments for people that are important in life, you know, with friends and family. And, you know, we never get through that journey alone. As I say, you know, we get through it together. So that's great. Not just you there, but everybody had some component of that. So it was nice to see for that. And I'll also ask you one of the same questions as I did with a couple people, but what surprised you most about the work that you did with your capstone? What takeaways did you
the thing that
take from it?
the thing that maybe surprised a lot was how data tells story. Like when you get a data from a source from anywhere, maybe a public source, you can use the data to tell a story, like cleaning it, analyzing it, then having a findings and answer for a solution. For example, my topic was a general topic in public health, where we can see obesity rate always everywhere. And I was trying to maybe to get the answer, like obesity rate is connected to life expectancy, if we say like that. So using data to tell that story or to find an answer for such a question was very interesting in this capstone project.
Thank you. Yeah, you know, it's everybody has their own takeaways, but yeah, certainly with data or understanding what to do with data. By the way, if anybody's ever working with data, never say I manipulated the data, which to us, you know, it means manipulating, cleaning it, preparing it. Never say manipulated, because I said that once in front of an attorney and they got really nervous. Not related to anything. I was giving a presentation once to some attorneys about geospatial things, and when I misspoke. I should have said, you know, cleaning and working and massaging the data, but even massaging I wouldn't use. I wouldn't touch any of those words. Little sidebar, fun note there for you. So I always say, you know, data editing or validating your data, you know, cleaning it, getting ready for a valid utilization there. So, but yeah, so validity is also another key thread that a few of the presenters have talked about. You know, we have data we hope that it's valid. You know, no data is going to be 100%, but we have to do our best to ensure that it's ideally collected for our purpose. And whether it's government data or whatever it might be, there are always threats to our data. You know, and some of them that we deal with more commonly are mortality threats, which simply means that our data is older. It's not as accurate. And how are we comparing older data to newer data? You know, some of our I think Vishnu, you're working with another presenter is working with different types of years of data, imagery, accuracy. How does that all play in? So that was good that you talked about the data sources and understanding that can be useful. if it's the right data for what we need. And the good news is data quality is getting better. And with that, validity does hopefully as well, so long as it's collected for perhaps the reason that you need it for, or that you can make good assessments of that in your methodology so that it is or becomes more valid. But other questions, comments for Burhan?
To comment, I think you did a good job with understanding like the data you were working with and the limitations. And then I liked your recommendations for future studies. I thought that was very clear.
Thank you.
Thank you, Ms. Angela.
Yeah.
Rob?
Hi, Burhan. I had a question. You mentioned at the end about you could do the same analysis on a finer scale at levels smaller than US states. I'm curious in your research if you came across sources of data for larger scales at, countries or continent level of the same data.
Yeah, I think I found out with the countries, but it was like not more than like 10 of them. So I try to use states instead of countries. And when I say like, if you maybe narrow down to, for example, let's say counties like, or cities, it could be better than even a state because you get concrete data instead of, getting everywhere from any state. But yeah, for country they are there, but not that much of them.
Cool. Thank you.
Thank you.
I
Thank
had
you,
one
Rob.
more question. He made me think of it. You said that the data was self-reported. Was it from surveys or is it from like reporting it to doctors? Or
It
do you
was
not know?
actually reported in government census, like
Oh,
various census.
okay.
So people were self-reporting sometimes. If you get like there, it was not like maybe if you are doing a survey, for example, the census survey, you have to self-report. So
Okay.
you may never know if it's accurate or not.
Right.
Yeah, thank you. Good comments. Any other questions, comments for Burhan? Otherwise, I know we were exchanging papers and had some good comments there back for you, but we'll continue our work with that, Burhan. But with that, I'd like, on behalf of Ms. Ansba there and the rest of the department, congratulate you all on making the journey to week 14 here. So everybody can get a little round of applause there for you. And we're not quite done, but we're getting closer. So getting this presentation done should hopefully allow you to reflect back a little bit and consider some things that you may want to add in or work through in your paper a little bit. And so that's the idea, the goal of our capstone presentations once again. But I will go ahead and end the recording. But again, special thanks to everybody who joined in, even from we had some folks outside the university drop in here. So thank you for dropping in. And we will look forward to wrapping up our class session here, and then I'll end the recording, and then we can hang out and talk about what's next. So thank you, everybody. Congratulations once again.